All right, here's another question, again raised by one of the participants. You mentioned that both PT and OT play important roles in treating Parkinson's disease. Patients usually come to us when they realize that falls happen a lot or dyskinesias heavily affect their lives. Could you please share with us the application or maybe some examples of high tech products in Parkinson's disease rehabilitation, especially which can help restore their motor functions? Thank you so much. This is a very tough questions for me because, for one, I am not a rehabilitation expert. I have not worked in PT and OT, and my information is limited there. And for second, I'm actually not very up to date on technology, um, um, innovations that are going on in Parkinson's disease. But let me tell you a few of the ones that I'm familiar with that may give you some ideas, may inspire you, may give you some examples of an approach on how technology is trying to improve Parkinson's disease rehabilitation. So one of the product that is the most polished product that we are using in United States, it's FDA approved and is doing some trials to go into review by Medicare for cost coverage. This device is a wearable sensor that patient wear on their wrist. It has a gyroscope that measures acceleration and deceleration, the peak velocity of the hand movements while they're doing different things. Like I'm talking to you, I'm moving my hand, and the device will capture any movement, how fast it happened, what was the speed of acceleration, what the speed of deceleration, and what was the peak. And then they calculate um, two different formulas taking into account of these movements, acceleration, deceleration, and peak velocity or average velocity. These simple information, two different scores. One they call the bradykinesia score or the slowness score, and one they call the dyskinesia score. The device is recording every 30 second, or last 30 second, and it creates a score or creates a number, and then it takes the last 2 minute recording or last four 30-second recording scores and average it out to create a score that is recorded and saved. Now, this recording is done every 2 minutes for 24/7, while patient is awake, and they can either take it off or they can keep it on overnight. And then it is done for 6 days. Now, what the device does is that it plots the scores of those dyskinesia algorithm and bradykinesia algorithm onto a plot that is an arbitrary plot based on the number. Whatever number they're getting from the formula, they put it on a graph, and then you get this plots of the scores. And then it creates, it uses a formula to do back averaging to smooth out the plot into a graph. So it takes all these numbers, they're spread out onto the graph, and then it smooths it out using a mathematical formula to create kind of a wave of patient's state in on that dyskinesia and bradykinesia scale. Now it basically plots an average of the 6 days, and then it also plots the maximum diversion away from that average or two standard deviation from that average, based on the 6 days of recording. What they did was that they used the device on normal people, on thousands of normal people, to figure out where those normal people are on that score during their time, or most of the time, or let's say 80% or 90% of the time during the day. And they created kind of like a graph or a line of where normal people are on average, and then they created a spread away from it. And what this device does on Parkinson's patient is that it gives a snapshot of how are the movements of Parkinson's patient different when measured this way compared to a normal people as plotted on the graph. So graph is basically a simplification of this complicated mathematical calculation that is going on. Mathematical calculation is what basically is pointing out that at any 2 minutes, uh, how different patient was as compared to someone else who doesn't have Parkinson's disease, on the two different formulas. One formula they suggest represent the state of dyskinesia. In one formula, they suggest that represent the state of bradykinesia. So you can tell that the patient was bradykinetic before taking the medication, patient improved after taking medication, and the patient had dyskinesia with a dose of medication. And you can see that on graph, and they have done it studies on thousands of Parkinson's patients to validate that this correlates with the clinical observation of dyskinesia. So that kind of a measurement of a patient's mobility in 24 hours is a very, very useful information that we do not have right now. So what we do is that patient comes in to see us, and we do an assessment of the patient over 15 minutes or 30 minutes on what they look like. But patients with Parkinson's disease change throughout the day, and what you're seeing may not be a representation of their average day, and it may not, if it is a representation of their average day, then you're missing the extreme when they're very dyskinetic and when they're very, very bradykinetic. So you not only need to have an average, but you also need the extremes. And all of that cannot be captured unless you follow the patient 24/7 for a week. And that's basically what the watch is doing. So those kind of devices that will do at home monitoring of how patient is doing with his movement, with his balance, with his speech, with his dexterity, with his tremor, are extremely useful and will be the future of therapy. They will give a true picture, a true snapshot of how patients' Parkinson's disease is being managed right now, in contrast to just an in-clinic assessment or in-lab assessment of the patient. So that's one example. Another example I will give you is that we recently did a study on orthostatic tremor, and we partnered with some PhD students from China and in a lab at UNMC and UNO. And what we did was that we took a simple iPhone and we used the internal iPhone's gyroscope, and we used an app that was available on the market that will give you an estimate of patient's balance or center of gravity. We had the patient wear the app of the phone as a belt, put the phone on their lower back, and then use the app to record what happens to the center of gravity when they feel imbalanced, unsteady, they start leaning and things like that. Similar app and similar devices that measure the balance of patient more accurately and dynamically in the clinic settings will be extremely useful. And then also something that they can wear at home, so you can do at home balance assessment, will be very useful. So those kind of devices need to be explored and understand. And then I mentioned the tremor devices already. We did a study where we used the phone to measure the tremor frequency, but of course you can use an Apple Watch or something like that, or a custom device. But I think custom devices, that in the past there used to be a lot of effort to create hardware and then a software for it to do the analysis. But I think there is less and less need of developing specific hardware, and there is an opportunity to utilize the smart watches that are already there and have a lot of tools in them and use those. So for example, there was a beautiful study done to use smartwatch, I think it was Apple Watch, to look at various aspects of Parkinson's disease, and to figure out what's the most reliable marker or the earliest sign of Parkinson's disease. And based on those studies, what we now know is the loss of arm swing, as we swing the arm, is the earliest sign of Parkinson's disease. The very first thing that motor-wise shows up is the loss of arm swing, but non-motor wise you can have problems with smell, you can have REM behavior disorder and other changes, constipation much earlier. But the first motor sign before tremor, before rigidity, before anything else is a loss of arm swing. Now that is easy to capture if you have a watch on the arm. The only problem is that the arm swing, the loss of arm swing may happen on a different arm, and the way it can be counteracted will be that the patient or anybody using smartwatch and using that app should be switching hands on which hand they're using the watch, and a smartwatch can adjust itself when you're using on left hand or right hand. And you can use that kind of a population monitoring to pick up early signs of Parkinson's disease, or you can use it for ongoing monitoring patient's own watch and create a program where it kind of keeps track of things like freezing of gait, things like postural instability and fall. Apple Watch can now detect falls, and you can use that to do a study on early incidents or onset of falls in patients, or underreporting of falls that Parkinson's patients do, and so on and so forth. So those are the few examples that I'm personally familiar with. There is so much going on in the technology field and technology area, and if I sit down and think about it, I can probably come up with some ideas on what will be useful. I know that the important questions that have still not been answered in Parkinson's disease are um, true monitoring of patient symptom, balance, posture. When does posture change happen? How can we improve that? There is technology already out there that teaches you, trains you on posture. You can put a small sensor on the back. Anytime you stoop, it gives you a warning and you straighten up. Those kind of devices that are already commercially available can be studied on Parkinson's patient to see if they can improve Parkinson's posture specifically, and can they be utilized along with the therapy. So you can go and use off the shelf on the market device on posture sensing. Actually, I bought one for myself to see how my posture is. It was horrible. I was getting so many alarms that I stopped using it. But that kind of device, there are so many on the shelf devices that can be used to address these balance, posture, freezing, sleep problems, soft speech, hypophonia. How soon does that start? Picking it up earlier in some ways, and home monitoring that I mentioned earlier. So those are some of the ideas that I had. Thank you.